So at this point, we're going to turn our attention to the last class of functions in this course, and these are logarithmic functions. It's a little bit difficult to see on the screen just because of the size, but the general form of a logarithmic function is y equals a times log with a base of b of x. A and b will be numbers. B is the base of the logarithm. It's related to the base of an exponential function. In fact, these two functions are actually inverses of each other. But for now, we're going to look at the characteristics of these logarithmic functions through their graphs. I have three of them here for you. And the first thing that we can notice is that the x-intercept of all of these functions is at 1. And that will actually hold true for all logarithmic functions. As well, if we take a look at the y-intercept of these functions, you can see that as we go further to the left, these functions actually start accelerating their downward motion, and in fact, these functions never actually cross the y-axis. So we have no y-intercepts. Which means that these functions will have vertical asymptotes, and these vertical asymptotes will always be at x equals 0. The end behavior of log functions will always be going from quadrant 2 into quadrant 1. The domain, and I'm just out of space here, I'm going to move this off to the left. The domain of all of these functions is any x that is greater than 0 because of that vertical asymptote. And the range of these functions will be all real numbers. They can go from a low of negative infinity to a high of positive infinity. They don't climb as fast as we get further to the right, but they do continue to climb. So knowing all of this, looking at this example, y equals 15 log x, one of the first things you might notice is that there is no base on that log function, and that is a shorthand way that it's done in math. This is actually y equals 15 log base 10 of x. That base of 10 is not commonly written, just as you wouldn't write 1x or you wouldn't put a 2 in the notch of a square root. It's just a shorthand because a 10 base log is so common. It's actually called a common log. We can have other bases, and in those cases, those bases would be written down for us, but if it's a base 10, it's omitted. So knowing what we know about the graphs, we have a few things we need to identify. The x-intercept will be at 1. We will have no y-intercepts. The end behavior will be moving from quadrant 2 into quadrant 1. The domain, x will be greater than 0. And the range will be all real numbers.